Hi everyone, my name is Eva Cantoma from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number or call me on any of these numbers, okay? Today we are going to actually talk extensively about Prota structure 2024, okay? Create a new project, and I'm going to select the template. Let me just name this. All right. Let's come down here and do something quickly. I'll make this 4 or 5. Four. Okay. Load generator. Load cases. Click on OK. All right. So let's have some cantilever here. Come to cantilever. But let's say 3 meters. Cantilever is 900. Okay. Let me have a cuff beam here. All right. Mind you, you can press your F2 to specify, let's say 1000, right? So this is at 1000. Okay. And then this is not where I want this to be. Sorry. Take that again. Okay. We can introduce some primary beams, secondary beams rather. So let me introduce it here. All right. I'll delete this. Let me make this story. Now insert, just say it. So okay. All right. So this is what we have. Let's introduce another set of beams from story 3. I'm just trying to explore all right. Let's go to, okay, I think I made a mistake. I'm supposed to have a beam here, so let me introduce a beam. All right. So let's say we have another, like it's staggered at this point as well. Okay. Okay. Oh, all right. So this is what we have. Um, let's insert our slabs. Okay. But before then, let me remove these columns that are here. Each story, I will just remove these columns. I don't. All right. Story 4. Let me have a secondary beam. Okay. Um, All right, so let's make sure we can be able to view this as story 0. If you come to story 0, you will discover that these are the only levels we are seeing. So let me come to story 1. What I will do is to go to support type. So this is my fixed support. I'll make sure I add this support. If I add this, I will click on OK. So now I can simply just highlight this set of columns and also hold on Control to highlight this set of columns. Right click, go to the properties, and then come to the support type, and I will select support and I'll click on OK. I'll close this. Now this is showing us that these are all what fixed. So at story 0, I'll be able to view that. Right? Okay, good. So let's go back to our model. Let's come to story 0 and 1. Let's try to insert some slabs. I'm supposed to have done that since, but then it's still not late. So I'm just simply going to insert my slabs. Okay. Okay, so let's say at this level we want to use like a flat slab. Let's come to so I will filter this. When I right clicks, filter selection, just the beams. So I will delete the beams. let's come here and insert although for this you don't have to go this way anyway. You can use axis region, right? Sorry, beam region. Can use beam region. I mistakenly selected this axis, and then I can use filter and deselect this axis. And I will generate it to all these entire floors. So similarly for this, okay, let me generate story 5 as well. What story is this? Story 5. All right. So let's say this is a flat slab. So I will increase the thickness of these panels at level 8. to 350. Okay, so I will introduce a drop panel here. So if I right click, I can come to drop slash patch slab patch panel, right? So layout, I want to sorry. So you can do similarly for all of them. This one. Like I said, 500. Updates. Alright, so you can see what we have here. So we can do similarly for all of them. Sorry. Right click, go to drop slash slab patch. So specify the depth, right? Click on OK. So similarly, you can select right click, well, I think I mistakenly selected this, but oh no. So that is how to remove that drop panel. So we are here now. So let's say at this level we want to have some steel members, right? So let's have some steel member at the roof here. So we have a steel column here. Are we at the right story? No, we are not. Oh, sorry. Alright then, so before we can do that, we have to introduce another story above this level. So I'll come to insert story and I'll specify 9. If I don't specify 9, if I just type in 1, for example, it will replace the story 1. If I type in 2, it will replace. That's basically how it is. So this story 9, it is going to be above the story 8. So I'll press OK and I'll press yes. So if you look at this now, a new story has been created. You can see the grays above the story 8. So let me insert my steel columns. Well, I've spoken extensively on steel. You can check my channel to find all of those tutorials there. So let's say we have these steel members here at this top. So here we are going to have a secondary beams. Come to this modeling, frames, frame group. Let me have it the other way. Alright, let's have it this way. We will have a composite slab. So sorry. This way. So I'm not going to really go into this in detail, just trying to show you the capabilities of your Prota structure 2024, right? So let's use our guts. Let's have a pull line. Let's have a brace. Let's brace this. So let's come back to story one. Yeah, let me quickly show you something. Let's say, okay, let's say we have let's come to load editor. If you check this, we are at if this story one. So come to wall load. So I'm just going to accept everything as it is. You know, we are just trying to see the capabilities. I have spoken extensively on all of this in my previous videos on Prota structure, right? So yeah, we've introduced our loads. So if you look at this, we have our wall load. Let's say we want to have a load here. Can come to points line and area load, where we have maybe like a wall load, which is this. You select the type of wall load, right? So let's say we are using this type of load. The wall height at 3 meters, because in your design there are tendencies that you will have some loads that may be resting on your slab directly, right? So this is basically what it is. Sorry, that has gone off. I'll take that again. I'll bring it to wall load, and I will specify the height of 3 meters. So let's say we just, sorry, I made a mistake there. I'm going to draw this here. Going to take off this, right? So you can see we have a load that is here. So you can do that similarly for every other aspect of your model where you have loads, right? Where you have maybe like a wall load that is coming directly on a slab. So all you need to do is just to come to your loading, and then just make sure you specify the type of wall, right? And then you specify, if you don't have any of those wall here, you can actually type in your values manually here, right? So let's say we have 3.43, and then here we also have, let's say 3.43 for example. So I can similarly just specify my so it's a wall anyway, but okay, I need to specify the breadth of that wall. Okay, so let's say we have another one here. To 50. Was quite unfortunate. I was not able to add that load on my building at this particular story entirely, so I will have to just do it by picking just one beam. Let me just pick a particular beam and add this wall load on it, and then copy to other beams. That is another way to do that. Anyway, so I will right click on it, edit load, and I will come to my wall load. Alright, so I will just simply just click here in order to add that load to this particular member. Alright, so that load has been added. I will click on OK just to take this off. Alright, I can just simply right click on it again and then copy the load. Since on all your building, on all the structural members rather, wall load is usually just on beams. So even if I highlight the entire model or the entire structure rather at this particular story level, and I paste, it is only going to paste on just the beams alone. Okay, so I will paste. So this is just one way to bypass that other challenge that we were having on trying to load on other on the entire structure. Okay, so all I will do at this point is to copy the loads. Okay, I can simply just highlight this, right click, let me use a filter tool so as to filter this filter selection. All right, let me just select just the beams. Okay, it's quite difficult to do this at this level, but let's come back to story 6 so that I can manually just paste that. So I'm at story 6. Let me try my luck at this level and see if it will work perfectly. I don't know what the problem is with the other floors that with this particular story that it didn't work. All right, so let's go to load editor. All right, I'll come to my wall load. Now let me try to highlight and see. Oh, perfect, it has worked. Okay, so I will just simply close this. So it's way easier to do it this way, most especially when you know you have your wall load on all the beams, right? Good, so you can see that has been achieved as well. We can do similarly for our story 7, right? Just come to edit, load editor, right? Come to wall load. All right, let's try it again here. And then just highlight the model. Right, let's wait for it. Right, let's go over this. Alright, I'm just gonna do this manually by just simply picking on just one, and then come to edit load, or I can use this one. Whichever one I use is still okay. I'll come to wall load, and I will do for one and copy and paste on every other beam, so you will still achieve the same result. Okay. All right. So I will click here and I'll click on OK. Right. So at that level, I will select the load. I will copy. Right click, copy load, click on OK and highlight, and right click and paste the load. Okay. Right, by now I'm sure you have gotten the concept of how to add your wall load to your model. Okay, so for some other parts I'm just going to leave it as it is. The next thing I'm going to do is just to try to analyze this model and then run the design. We'll just come to my analysis, go to my building analysis, and I can just analyze this. Analysis. You can run a building model check. Is very important, so as to know if you could have some overlapping in some cases. You see, these are all the possible errors that you can get in your model: overlapping slab, overlapping column, overlapping slab with beam and walls. So these are all the possible errors you can get from your model. So if you are getting any of this error, then you will have to come back and check your model. Okay. And then I'm just going to run the analysis of this design. Okay, so I'm going to check everything. As you can see, we have a composite beam in our model, right? We have a steel member in our model, right? And we have a beam. We have, these are reinforced concrete. So I'm just going to check all of this. All right, and then I will run the analysis. So it may take a while depending on your system capacity. If your model is this large, that will determine how fast this analysis will take. Okay, so so we will have to wait for it to finish loading. Right, so I will click let me click no. Okay,
So after the analysis, um, I will come to post analysis to check my designs. Okay, so you can carefully go through to see all of this. All right. Okay, so I wouldn't go deep into checking all of my design reports and all of that, but as you can see for yourself, you can see how it works for each of these. You can simply double click on each of these member, and another good thing is you can group similar members. Okay, there are cases where you have similar beams, similar columns and all of that, so you can do a grouping. You can group them. Now if you come to automatic group, you can group all similar axes. Okay, so group, it will help you to group all those similar beams that you have. Okay, so because if you are familiar with manual detailing, you agree with me that there are a lot of cases where you have similar beams in terms of their length, in terms of the reinforcement, in terms of the load that is coming on it, so they are similar. So in that case, you don't need to keep repeating similar beams on your detail. Okay, so that's basically what Prota structure does for you. For every structural member, you can actually group. Okay, so I wouldn't go too deep into checking all of that. I believe if you have been following on a Prota structure, you will agree with me that I have spoken extensively on all of these things before. Okay. Um, all right. Let's come to. We have been able to do our analysis 100%. Although some of the members have failed, but I will not go deep into trying to fix those structural members that have failed. I knew that there will be some members that will fail, most especially for this beam. I'm sure there is a high tendency that it may fail. These ones, they may most likely fail because of the span. So in that case, the best thing to do is to increase the depth of this beam. But although I'm not going into that, as you can see, I just use the default cross section of each of those structural members that was given to me by the software itself. Okay, um there is another very important aspect that I did not actually really touch. If I'm to go into that, I will have to reanalyze this all over afresh. But what I will do is I can quickly let's say I delete this particular slab at so I'm going to delete this. You can see the analysis is no longer going to be valid anymore, so I will have to reanalyze afresh. Okay, but nevertheless, let's just delete this. So I will delete it across every other floor. Okay, so that I can introduce, let's say we have a shear wall here. All right, so let's say we have a shear wall here. So that will be on all the floors. I will have to come and I have to delete this particular slab across all levels. Okay, so what I will do is I will pause this video and go through each floor and delete it. Okay, So I have been able to delete the particular panel across all levels. So but let's go to our story one. At this story, I'm just going to create it inside here. If I said I should create it along this edge, I will have to delete each of these beams and delete the columns, and it's going to be a lot of work. The easier and faster way to do this, this is really not a live project per se, so we are just trying to explore and see what we can achieve with our Prota structure software. Okay, but then some of these challenges are important for us to go through some of this in order for us to have a better understanding when we are faced with similar challenges like this. All right, so I will just, let's say this grid is here, and let's say we have for this, let's say I copy this or use offset. I won't specify any distance, I will just drop it. Let me just move this a bit. So assume here is the center. Okay. So I'm going to draw a core wall here. Mind you, this wall is going to be a shell. You can see it's a shell wall, so it's reinforced concrete. So like I'm just going to draw this. Oh, sorry. Let me create another grid here. So this one, I'll set it around here. I will leave it here. So I will draw a core wall. So let's say this wall is here. It goes this way. I have another one coming this way. Another one this way. Another one this way. So what I'm going to do is I can simply let me just select because there is no much space for me to highlight it, so I can simply just select and merge these vertical walls. So you can see I just merge these walls together. Now it has been merged, right? I can right click on it. It has become like one single element, right? If I right click on it, I can come to polyline wall editor, right? And I can insert my reinforcement on these walls. Okay. All right, so we are here. We can use the automatic curtailment. So if I click on automatic curtailment, you can see this is basically what is bringing out. I can add a head zone. I can specify the corner bar diameter, which is the bar diameter. Okay, so however I want this to be, I can specify all of that, and then I will click on OK. Now you will discover that your entire reinforcement detail, you can see, has been generated on my core walls. So I can simply click on OK. These core walls, now I can generate this member up to story, from story 2 up to story, I'll hold on shift up to story 7 and I'll click on OK. I have already tampered with the analysis already, because the moment you do your analysis and you add any member, any structural member, or you edit any member, that analysis will become invalid. Okay, so you will have to reanalyze your structure again. Okay, so that is that. The process is complete. So it's complete. I can just close that if it's done. Right, so let's view this and see. You can see this core wall has been generated, right? Okay, that is that. I just wanted to demonstrate this. Let me show you one other feature. Although it's not really very new, but I know a lot of people don't really get to know how to do that. You can see I just use my polyline. I can use my polyline to achieve any kind of shape. I will right click here and click on continue with arc. So you can see this is the shape I have. Let me show you something very interesting. I can just right click on this and convert to column, and you can see that has been converted into a column. So all I need to do is to specify the cross section of this column, and I can look for a grid and insert this column. So you can see that column has been generated for me. You can see how very interesting Prota structure is, right? It makes your work way more, is becoming more flexible by the day. They are really working seriously on these softwares, and it's becoming way more flexible and way more easier to actually model with. All right, so we have been able to cover extensively on most of the basic common tools that you most likely use in your Prota structure, right? So right, so I've been able to do that. So the next thing I'm going to do, let's go to our, sorry, I may not reanalyze this because it's going to really take so much of our time to reanalyze this all over again. But I'm sure you have been able to see how to come about your analysis on Prota structure. So I will just quickly insert some beams here. I'm just going to show you various kind of foundation that you can achieve with Prota structure. So this is going to be a strip footing. And I will select some columns and insert some pile tabs, so we can have some pile foundation on some of the columns. This is just me trying to explore. Insert a pile cap. So I'm not really going to go deep into explaining the pile I think the it's telling me the analysis is not up to date, I think. So we will have to reanalyze it. So we don't have a choice. Analysis result is not up to date, so I have to reanalyze this. We don't have a choice, so let's just reanalyze this. Okay, so let's run the analysis. Let's just run the analysis. Okay. All right, so we have been able to successfully reanalyze our model, right? So we can come back to our story 0 to quickly insert. Let's say we insert our file tabs on this particular columns, right? All right, it's loading. All right, I'm just going to accept whatever it gives to me. This is just to okay, so you can see what we have there. Similarly, you can also insert pad footing. You can insert pad and right click and insert pad. Okay, so I'm also just going to accept this as it is. You can do a raft for this. You can use a rectangle to draw around where you are going to be having your raft. Okay, let me draw this around here. So let's say this area is where I'm going to be using for my raft, right? I can insert the thickness of the slab and just so this is my raft. I'm going to be generating here as raft, and let's say this one is a strip footing. Although if you look at this model, I think this one and this one are not going to be relevant. So this is just where we have this. So let's say we have this as a strip. I hope it will allow me insert my strip footing. I just deleted the structural member. I can't. Okay, fine. But we have been able to get the concept so far on how to generate most of your like the pile kind of foundation, the pad kind of foundation. Your strip footing is the one we were just about to do. All you need to do is just to right click and click on insert strip footing, and it will be inserted. It will pop up a menu for you where you have to specify the width, the thickness of your footing. Okay, although there is more to it, I have spoken extensively on each of these types of foundation already in my other videos that you can find on my channel. Just visit the channel. Just go down below the description of this video. You'll find the link to the YouTube channel. Visit the channel to keep yourself busy. Okay. um if I come to slab strip, I can simply just strip this. I pray it will be able to run the strip because of the analysis is not up to date anymore. So I'm going to use a fixed band strip. So I will strip this way. I can hold on control in order for me to get a straight line. So I will click this point and click here, click this point and click here, and I will update. So you can see it has covered the entire area of this strip. I can switch this to y-axis, and I will do similarly. Hold on control to draw my strip. I will click here and click this point so that it will cover the entire area, and I will update. So we have been able to generate our strip at this point. All I need to do is to just come to my analysis and go to my FE foundation analysis. I can be able to I'll click on floor mesh and analysis. Supported vertical member detected in upper level. Yeah, we have other members at the upper level. Remember, based on, okay, you can see the Boolean analysis is not done, so I have to really run the entire analysis all over to be able to achieve that. But so far so good. As you can see, we have been able to extensively cover I think the major parts of our structure using Prota structure 2024. You can see how flexible and how interesting it is. You don't have bugs compared to other previous versions of the software. You can see everything so far so good has been going very smoothly. Let's try to go to our Prota still and see if we can be able to do something there. The analysis is, please analyze the model first. Oh my god, this has been my major challenge with this. Because of how large the model is, it usually takes a bit long time to really achieve the entire analysis. But I will have to reanalyze it. By the time I analyze it, and then we can be able to view the steel members, be able to touch some of the major steel connections in our Prota steel, and then also go into our Prota detail, generate some of these structural members you are going to see for yourself. All right, so let's reanalyze it. As you can see, you have to keep reanalyzing the moment you make any change on your model. You have to reanalyze it. Okay, so you can see it's showing me a red indication here, like a star, showing that this analysis is no longer valid. So I will have to rerun the analysis. Another thing about this is that when you The software has what we call, when you go to your visual interrogation, there are a lot of features you'll be able to easily see that will help you to know some of the structural members that have failed, some of the structural members that have passed. Okay, you can see here is what we call the visual interrogation. So you can see this is our design statue. If I click on OK, you can see it brings out this table for me, showing me that the red indication means it has failed, the yellow means warning, and this means it has expired, and then the green is okay. This one means do not design, and then white is not designed. Now because my analysis is no longer valid, so that is why we are not seeing any red in any green indication. There is tendency when we analyze these, most of them may pass and probably some of them may fail. Like I told you, if you could remember from the previous episode, I made mention the fact that this structural member will most likely fail because of the span and the load is carrying here. But I'm sure if I increase the depth of these beams, high chances are that it will pass. Okay, but that is from practical experience, sorry, and from years of experience so far, I can be able to tell. Okay, so let's reanalyze this. Just come to your analysis and click on building analysis, just like we did earlier on, and we'll just rerun the analysis all over again. So this is the third time we are rerunning this analysis. After this, we will not go into analysis anymore. We'll just go straight into generating our detailing, so that we can be able to see what the software will be able to generate for us.
All right, and welcome. So let's continue from where we actually stopped. Okay. So do you want to reassign default river pattern? Okay, or just click on no. All right, so we are back here. The analysis is done. I will click on OK. You can go further to check if all the steel members have passed or failed. If you come to your design, you can check your steel members that have failed and those ones that have passed. From here you can see the steel columns have passed. You can check your frames, you can check your braces, pull line, your guards, your truss. If you have your dome, you can as well check all of that. Now good, if you look at this, you realize that some of the members have failed, like these ones. If you check the shear wall here too, some of them have failed at this level. Okay, so basically this is how it works. Okay, but since we are at the story 0 here, let's still see what we can do. Let's just proceed by inserting our strip footing. So I'm just going to, mind you, you can take out your time to, you can design envelope then just click on design. Okay, and I'll click on OK. The footing bar size you can select and all that even before clicking on design, so all of that can be done. The left hand side cantilever, the right hand side cantilever is going to be 1 meters based on what I specify. I can remove the cantilever as I so please and click on OK. And then if I make any change there, I will have to click on design again. All right, so this is basically how our strip footing is going to look like. Similarly, like you can as well do a combined footing, but this is not advisable to combine these two footings. They are very far away from each other. Okay, but if for example you want to combine these two footings, you can select the two and click on insert combine pad footing. So similarly for pile as well, so you can have a combined pile cap. Okay, so that is that. Let's go straight down to our steel so we can see what we'll be able to achieve from our Prota steel. So we are here now. Let me come to my drawings and reports, and I'll go to my Prota steel. Alright, so you can see the steel is loading. Alright, you can see it's importing frames. Alright, so I can close this. The steel is going to load in the background. Alright. Okay, so we are here. Like in Prota steel, the only thing we are concerned about is this the steel members, right? So as for the concrete, even if we highlight them, nothing is going to really take place. Okay, so this is basically the interface for our steel, our Prota steel 2024. Similarly, you can just right click and come to your IntelliConnect and click on create line connection. Now you can go automatic, which is this. You can see it's on auto. If I click on next, the software will by itself select the most suitable kind of line connection for me, and I can just click on run and it will run that for me automatically. Similarly, while it's still highlighted, you can see that connection has been created for my pool line. Alright, I can also still right click and come to IntelliConnect and click on create that connection, and I will click on next. I will click on run. Okay, I will also right click, come to IntelliConnect and click on, I think I have sag rods on my guards. I also have sag rods. So you see some of this sag rod could not be connected, right? You can manually do for all of that. So but then I may not extensively speak on all of them because I have been able to explain all of these in previous videos where I spoke about each of these connection. So I will come to, okay, I have a base plate, but let's do for base plates. You can see this one has a lot of stiffness here. So whichever one I want to really make use of, but let's say I want to use these, I can click on run. So normally you can as well achieve your base plates manually. I have created videos like that on your base plate. Same thing goes with other previous versions of the software. Base plates normally you tend to have some level of issues with creating that connection automatically. But then let me try this simple base plate with design and see if that will be created. So I encountered the same challenge, but nevertheless that can be created manually. I have done quite some number of videos on that. Okay, I may still touch it a bit, creating it manually. Okay, let's try the brazing connection automatically. Okay, it's done. Let's come to truss connection. So you have to specify the thickness of your gusset plates, right? Okay, all of that is done. You can see these are the gusset plates, right? These are the gusset plates that was generated automatically for us. Okay, let me still right click, come to floor beam connection. You can see we have this stiffened end plate connection macro, the fin plate connection, beam to beam end plate connection. However, whichever of these connection, but let's see, I just click on next. You know, the software uses a level of artificial intelligence to check your model and create all the necessary connection where it's supposed to be, but it's usually not 100% as intelligent as a human can be. I'll put it that way. So some of the connections you will have to create them yourself. Okay, so let's come to column slash beam connections. Next, next, next. Now run. So you will agree with me that most of the major connections here has been really generated by the software for us automatically. Okay, one very interesting thing is that some of your structural members here, you can see by just right clicking, and when you click on the properties, you can as well use from these properties to rotate any of these members. Okay, you can rotate any of these member. So let's say I add here maybe 100, and I click on apply, and I click on OK. Right. Okay, so I was able to reverse that anyway. Let's come to our base plate here. You can see we have several base plates we can use. Let's say I'm using this with this stiffness. I will just right click. Once I click on the member, I will right click, and that base plate will be inserted. So if I want to add a anchor bolt, if you come to miscellaneous here, you can simply just if you right click on it, you see it brings a menu for you like this. It shows you the geometry. You can increase this hook angle. You can also rotate these bolts if you like. Okay, so but you would have to place them to know if there is any need for you to rotate. So let's say I select this anchor bolt. All I need to do is to right click and select the base plate. Now you will see that that plate has been, the bolt has been created, and if I tend to hide this member, I will be able to see that anchor bolt. Now this is where that rotation is very important. Okay, it's important to rotate your bolt. So if I type in 180, let's see what we have for this. Okay, good. So you can see I've been able to rotate this particular bolt. So this is just basically how to achieve your bolts. So if I'm taking this way, is this supposed to be 90? Okay, yeah, that's right. So similarly, I'll just click apply, click OK. So this is basically how to achieve all of that. So even if you are not able to use the the IntelliConnect to place your base plate for all of them, you can manually insert your base plate, and there is a way to create a base plate manually. I have spoken extensively on that too as well. So you can visit the channel to see all of that for yourself. All right, so each of these member, like this, now you can see I can increase this height of this column. For example, if I want to, if I double click on it from here, the Prota steel, you can see it brings the geometry of this particular steel column, telling me this is the height of this steel column. You can see at the end here, this is the start, which is the bottom. This is the end here, which is the top. Now at this bottom, I can increase this height. Let's say I increase this by 200. I can click on apply and click on OK. You will discover that this has increased, right? So but then I will take it back to the initial height. All right, so I will leave it as it is here. So you can do that similarly for every other column. Right, let me see if I can show you some can see some beam to beam connection, beam to column connection, which is this. So you can see every connection. It will give you a little preview from the diagram here, showing you where those connection is supposed to be used. You can see I can use my hunch connection for this. The macros have failed. Okay, let me use this stiffen end plate. Okay, so the connection has been created. Okay, I think I had
Oh, there was a connection that is here already. So I think that was why that didn't work. Let me try this hunch connection here. Hunch. Mind you, you can select 3 members. So you can see that hunch has been generated here for me. Okay, so all of this actually works and they work perfectly. However, you as the engineer, you use your discretion to select the best connection that suits every structural member. Okay, and again, you can create more details for each of your connection. Let's say for this particular beam to column connection where I have this here. Sorry. So if I highlight this, I can click on detailing item manager. So if you click on detailing item manager, I can name this beam column connection 1. Okay, so however, you can just shorten it B to C on, right? 1, and I will click on add to ask me to select. So I'll have to select like a primary member. So I made a mistake. I am going to take that again. Highlight it, click on detailing item manager, B to C connect 1. I'll click on add, I'll click on select. So if I click on select, I can select this, so like a primary and a secondary member, and then you will see that will be created. You can see this box, you are going to see where this will come to play as we proceed. So you can do that similarly for all of this. You can do it for this as well. Just this will be truss connection 1. I'll click this, I'll click on select, click on this, click on this, I can just press enter. Now you can see that has been generated here as well. So you can do it however you want for wherever you want it to be. Okay, so let me let me do it for here as well. So here we have the okay, let's see, connection 2. Click on select, select this, oh, I think that's way too large. Okay, trust. Okay, I think while I was highlighting, this other part of the connection is being selected. So but basically this is just the concept of this connection. Just click, click. Let me use this. Okay, fine.
that has been created. Okay, so you can take out your time to fix in or select all the necessary connection you want to use. Just you can use this detailing. It will give you the detail of each of these connections. That's basically what it does. It gives you the entire detail of this connect. It will be good for me to capture this as well. Call this B to C connection 2. I will add, I will click on select, select this member, select this member, and I will press enter. Alright, so that is that. I will leave it like this and I'll close. Right, so you can actually create views from your grid, okay, and you can also create views from here if we use the view by either 2 points or 3 points. So if I want to do the view by 2 points, if I select here and I select here, hold on. Okay, I'll take that again. Okay, so I will take that again, view by 2 points. If I click on view by 2 points, all I need to do is to select 2 points. Okay, so trying to select 2 good points so that so if I select here, and then I select here. All right, so you can see that view has been created for me. However, you can select any 2 points. That will be done for you automatically. So you can see this view has been generated however you want to. This is your view. So if you double click on it, you can rename this. Okay, so however you want to name it, either view 1 or view 2, however you want to name this, you can actually name your views. So you can switch back to your 3D. This view is very important. I'll show you where that is going to be useful for us. Okay, you can create an assembly drawing either by parts, or you can create, so you can create by either parts, create drawings by parts, or create assembly drawing. So if I select that member and I create on parts drawing, for example, so sorry, I will have to perform what we call numbering. Okay, so all you need to do is just to highlight your structural members. Okay, when you highlight, so when you highlight, you go to your drawings and reports, you click on perform numbering. Very important. You can apply, it's going to perform numbering.
for all your still members. So you can see it will tell you, okay, let's just write on, I'll show you something very interesting. Oh my goodness, it's taking a long time. All right, so I will click on OK. I'm just going to close this quickly. So each of these member, I can just come to create, whether by parts or assembly. So creating parts drawing. So I think it's done. All I need to do now is to press on F6 or double click on this drawing manager. So however I want it. So if I double click on it, you will see that that has been created. All I need to do, I can create and give it a name, whether, okay, so if I open, so the drawing has been, you can see this is a part drawing. It does not include the connections, right? You can see this is just the beam. It's telling you the beam, right? The connection is actually not included. So similarly, we can go back to our 3D model, right? You can see this this is the drawing that has been generated for us. But let's go back to our 3D model and see what we have there. Sorry, you have to click on model view, so it takes you to the model view. So this time around, what I will do is to right click and come to interconnect. Sorry, creating drawings. I will click on assembly drawing. So you are going to see that there will be a difference in the drawing that will be generated. So I will click on F6 to take me there, or I can double click on drawing manager. Now this is the drawing that has been generated for me, so I can click on open drawing, right? So I believe that would have been created already, so I can simply just close this. Now you can see this is what I have. This is now the assembly drawing.
this is the basic difference between having a part drawing and an assembly drawing. So on assembly drawing, you can see every connection that is on this particular member was actually generated as well, right? Like it's fully well detailed compared to where you have just the parts drawing, right? So this is basically what part drawing and assembly drawing actually means in Prota structure. Okay, you can see a table here is also generated for us. Okay, okay. Let's come back to our model view, or let me stay here. On this now, where I am here, I can actually create a, you can see the entire 3D view has been generated. So if you look at this 3D model, you will discover that this model looks a bit more difficult to really interpret. So we can do some little changes to this model. If we double click on this here, it brings this menu. You can change this to a hidden line. You can come to your filter. You know, this is on general. Change to hidden here. Come to filter here. You can click on filter. This one, I can change this to 3D, unlimited. Click on filter settings. I will select profile, select weld, select plate. So these are just what I want to include. If I click this, I click on apply, and click on OK. Now you can see our model is looking way more better actually than the previous one we had, right? Okay, all right. So if you could remember, although we've hidden some of the members, but let's see. Right. Okay. Hold on. I need to do something. Okay. So if you could remember, we're able to get to this point where we're able to generate just a particular structural member. You can repeat that process for all of them. Okay, I just quickly want to go back to my model. Okay, sorry, I think I minimized something, and oh no, this is not what I want to see. Okay, it's behind. I can't find it. I
think this is it. No. I minimized it just now. Okay, but then we can just double click on this and get back to it, right? Right, so we are here. Um, so there is one very important settings from here that you need to bring out. So when you come to filter settings here, and this solid, very important. Okay, make sure you turn on this solid, and so that you will be able to have those those uh, those particular connections that we highlighted. We want to generate a special, we want to generate their detailing so that we can be able to have more details on those connections here. So all you need to do, once you have your model here, you know those areas are already been cycled. You are going to see them cycled. If you come to your tools here and click on connection detail drawing, automatically the software will generate those detailings for you for those connections. Okay, so let's wait for it. It's loading in the background, and let's see what we have here. So mind you, the only member I generated assembly drawing for is just my columns. So you can do repeat that same process for all of them. Okay, so you can see all our connections have been generated. You can see the connection here, and then it's going to come out based on what I labeled it as. So this is B to C, that is beam to column connection 1. This is truss connection 1. This is based on actually the name I gave it. Okay, and it's going to come out exactly for me that way. But there are some more information I would like to show you. Okay, I think this will make more sense if we generate our cross section. There was a cross section that we generated. I can't remember. I think it's not here. Let's create the section all over again. Sorry, I'll come to my model view. Let's come back to my model view. Okay, it's loading. Okay, so on this model view, let's say, okay, look at that view. How was I not able to see that on so I can find it here. The new view is here. So let me come back to my drawing. This is it. So this is that view that I was able to create the other time. If you could remember, the name is new view. So if I create a view, this is not what I want. Oh, this is not what I want. Yes. So let's go back to the model view. Sorry. All right, let me just quickly create that, right? I think something is wrong with this but let me just, okay, there were some elements that let me show everything. Okay, yeah, I hit these particular slabs, if you could remember from the beginning. Let me create a view by 2 points. So I'll click here and I'll click here. Sorry, I have to click that properly in order for me to create. So that is my first point. Let me zoom properly to see what I'm doing. This is my second point. I'm not getting it right. Okay, let me create this from let me rotate this a bit. I think it's going to be better this way. So you must position it properly and better, or else you won't click this point and click this point. Okay, I'm not getting it. All right, let me use it, or let me rotate this building. Okay, I think I've gotten a better idea of what to do. My major focus is the steel model itself, right? So I'm going to just pick this section from here. So let me rotate this properly. Oh my god. All right, let me use this point and this point. I think it's going to be way better for me. So I'll pick this point and I'll pick this point. Okay, now you can see that has created okay, didn't capture the steel, member. So I try to come back. It's giving me this. Sometimes you can just use your property here and make sure you bring everything back to 00, and then click on apply and click on OK. Your entire model will come back, right? And then so well, sometimes when you have issues like that, I think it was showing as a wireframe, This was how it was showing. You can click on this drop down menu, change it to either solid or change to contour solid, however you feel is going to be way better for you. This I will have to get this honestly, or else I won't. It's not a much of a challenge. So if you are not picking it at the right position, you know, we have our base plates at that point, so I'm sure I'm not picking it correctly. So but let's try it around here. I'm sure it will we'll be able to get it right. So I'll pick the first point. Make sure you are picking it. You can see those that line there, like a showing like a perpendicular sign. Similarly for this, so once you are able to get it here, it should work. All right, so this is our view. So I can as well name this view. I think this should be it. I can rename it to although I'm not sure if this is it. I'm seeing another new view, but let me just name this one too. Okay, good. This is not what I want, so I'm going to close this one. So this one is what I want to use. So let's go back to our drawing. This one, I will just right click on it and click on create viewport. So I'm going to have it here. So you can see these are cycle, although this is the 3D model, right? So we are in the right position. You can go as far as taking the dimension so as to know what is the length from here to here, here to here, before you print out your drawings, right? So all you need to do is you can come to your dimension and use the horizontal as the name implies. Pick your points to know what you have. You can see automatically it's giving me the distance of these 2 points, right? So similarly you can do for, although I made a mistake there, so you use the horizontal dimension for horizontal lines. So this is what I have, the distance from here to here, right? So if you want to do for this, you can as well do that. You can pick 2 points. Sorry, let me take horizontal, click, click, click. You can see I'm able to get for multiple points. Once I'm done, I will just click the last point and then I will right click. So you can see I've been able to get the dimension for this. So similarly you can get for the vertical as well. So if you are very conversant with your AutoCAD, I don't think using this should be difficult for you, right? So this is basically how to use this. And for your align, just as the name implies, you can use it for in a case where you have a member like this. You can pick for your align, right? pick, right click. So this is what you have. So this is basically how to use this tool. Let's see what else. Although I was trying to explain annotate selected profile, annotate settings profile. Now you can annotate any profile. Okay, so all of these our details, you can see, although it's well detailed, you can see this one is telling you this member UKA 90 by 90 by 8. Okay, so all you need to do is just to select that member, and it brings out it tells you what structural member. Right, so we have spoken extensively on all of this. Let's come back here and see if there's something I can still say about so let's wait for this 3D. Right, this is just giving me some, I'm limited to this. I don't know, it's not switching the views. Let me come back to view, come back to 3D model. So once it gives you something like this, just right click, come to view properties, make sure you change this to 0, also change this to 0, apply and click OK. So the entire model will come back, right? So each of these connections, you can see we are under view. You can do something like the color coding, so as to know the members that have unchecked, unrelated, that have failed, and the members that have passed. So you can see most of the members are not related. Some of them are unchecked. Some have failed, like this connection have failed, these connections here have failed, and then some of the connections have really passed. So if you want to get some detailed information about any of these connection, you can simply just double click on it. You can see it's telling me the thickness of the plate and all of that. So some of times these failures could be as a result of maybe the thickness of your connection. You can go a long way by changing some of this information, the detailing information, the geometry of this particular connection, and then by so doing, it may, some of them may pass. You have to keep trying until you get the best thickness for each of these that goes better. And then if you come to your drawings and reports, you can generate, you know, the essence of Prota still is to create connections for your still members. Most especially I think that is the basic reason for the Prota still, in order for you to create connections for your still members, and you can generate a design report for your still members. So you can see I have been able to select this particular gusset plate. I can as well view the design report for this particular plate by just clicking on it. Come to drawings and reports, and then if I come to create, you can see I can be able to view this report. This is the report that has been generated for me by the software. So by just, if I double click on it, I should be able to access these reports. You can see that the report is actually very great. Let it open so that you can see for yourself. You will see it generates even with a diagram, shows you the entire calculation. So you can see this is it. Let me open this. You can see what I have. So it tells you everything. You can see the based on this well shear resistance, everything here has passed. So if you view the report for those particular members that have failed, sometimes you realize maybe there is just one thing you need to do for it to pass. Okay, so if let's say I click on this connection and I come to my report to view the reports for this, there are tendency that you will have maybe for the major part of the connection may pass, maybe just one aspect of it that would fail, that may probably require you to actually make a little change and then it will pass. So it's really interesting. The software is really great, as you can see for yourself. It's a very interesting software, a very powerful software. I believe by now I have been able to talk extensively on Prota structure, Prota detail, Prota steel. Although we've not spoken about Prota detail yet, so we'll go to Prota detail to demonstrate for us to see what Prota detail can do for us. All right. So if you view these reports very well, it's just like I said, you will discover that the bolt bearing capacity has failed. You can see the bolt group shear resistance for the major part of the entire work. You realize that the connection has passed in some of the major areas. The end plate in shear has failed, so you realize it's not a very serious failure. So in that case, we'll just probably have to do some little adjustment and all of this will be satisfied. So you can see this is 92.73 kilonewton, is greater than or equals to V116.67 kilonewton, right? So once you do this and it's satisfied, this will definitely pass. So so far so good. I'm sure we have been able to do some little justice as far as review is to Prota structure 2024. So what I'm going to do is to, sorry, I don't want to close this. Okay, I can leave it open while I come back to my Prota structure. Like, you know, the Prota structure is where you do your entire model of your work. The Prota steel is where you do your steel connection. Then the Prota detail is where you do you generate the detailing of your reinforced concrete designs. Okay, so like, you know, the software is in three models. We have the Prota steel, the Prota structure, the Prota detail. Although now we have the Prota BIM, where you can easily integrate between Revit software and Prota structure. Maybe as we proceed, we are going to also talk about that. But as far as this review is concerned, we may not talk about the Prota BIM. But as we go further, I'm going to show you how that works as well. So let's as you can see here from the Prota structure directly itself, you can view some of your detailing. Okay, like you can see if you come to your drawings and reports, for example, if I just want to have a little glance of how my detailing looks like, because the Prota structure itself, the detailing itself, there are a lot of settings that you may probably need to do, how you want your detailing to actually appear. It's very important because you can do your entire design and then the detailing may not be well represented as you want it to be. Okay, so there are a lot of settings that you may probably need to do. So if you come to your settings and settings center, you will see all the list of structural members. You can see they are here. You can see we have column and shear wall is here, the beam is here, the slab, the foundation, the staircase, retrofit walls. They are all here. Mind you, I didn't talk about form work. You can create a form work for all of these. You can create a form work. Okay, a form work can be created for all your structural members. You can create a form work for them. Okay, so but then let me just quickly run through and show you some of the rebar. You can see this one is for the design. Okay, but for rebar, which is the reinforcement bars, that's basically what it means. You can see the column containment. You can see here single links, all of this, although I may not talk about this, but if you look at let's come here. You can see from here you can be able to specify each of your structural member, although from your building analysis there you can as well specify your reinforcement bar on each of your structural member, but you can as well do it from here too. Most especially for slab, I will always advise that by the time you set it in your building analysis, when you go to building analysis, there is a provision for you to make adjustment to the size of the reinforcement, the grade of your concrete, the grade of your steel. Okay, although I probably did not show that part, you know, the software is somehow a bit wide as well, so the review may not necessarily be able to touch every area, but we'll be able to at least touch some of the major aspects of the software in order for you to just have a better overview of how the software actually works. You can see this is the slab rebar. Although let's come back to the detailing aspects. You can view the detailing of you can see this is basically how the detailing for your column is going to look like. You can adjust, arrange your settings how you want it to look like. You can see the outside of the longitudinal bar, that's the lateral web bar placement. So if I change this to inside, you can see it has changed from the preview. What that means is that in my detailing of my column, this is how it is going to appear. Okay, so you can set this according to how you know your detailing is represented in your country. So however you are going to do it on your site, that is basically how you should set it. Okay, so that is that for column. You can see for the elevation, you can take out your time to go through all of this. Is very important because whatever settings you do here is going to affect your detailing when you go to the Prota detail itself. So these settings are very important for you to actually do. Now if you come for your beam, similarly, although I'm not going to look at all of this, but I'm going to come straight to the detailing here. Okay, so you can see these are the basic information: number of beam, elevation per insertion row, horizontal spacing between elevation. Let's come to curtailment. Good. Now this place, at this place you can actually change this to however you want it. It has options for you to lap bar inside support. So the moment I click on this, you will realize that there is a change. automatically. If I bring it back here, you realize there is a change. Okay, so it's very important for you to actually arrange your detailing, do all the necessary settings you need to do from here on all your structural members before you take them to your Prota detail. So similarly, just like we did for the column, for the beam, is the same way you do for the slab, the same way you do for the footing as well. So this is basically how it's like to arrange your settings. There is more to these settings beyond just the detailing, but it's important that you come through and go through all of this yourself so that you can understand what is going on there. You can see, if you come to the project preference here, you can see here calculated by, you will have to type in the name of who designed this project, who control the project, who draw this project. It is going to be presented by who, then who is the client, the project title, propose 10-bedroom duplex or 5-bedroom duplex, however, whatever is the name of that project number, what is this project date, let's say October 2024, for example, project address number 14B, Kamuru Close, Karji, maybe Jos, Plateau State, however. So these are basically the major settings you need to, by the time you put this now in your report, when you generate your design report, all of these informations are going to appear there. Okay, so if you leave it blank, it is definitely going to be blank on your report. So it's important you do all of these necessary settings. Although this video has already been able to cover extensively, this is the part 4 of this entire review on a Prota structure 2024. All right, so in the next episode we'll be going deeper into showing you how to actually generate your detailed drawing in the Prota detail. Okay, but then quickly, maybe if I must have skipped some part of these very important settings, if you come to your building analysis, this is where you will have to set the grade of your concrete, the grade of your steel that you want to use, the size of each structural member, the size of each steel grade, steel member you want to use on each structural member. Very important that you come and arrange all of these, or else by default the software has a default settings, and some of these reinforcements may not be very available in the market for you, so you have to do all of those settings and arrange them. So this is one very important settings that you must do. Okay, so you can see by just simply clicking there, automatically it brings me here listing all the grade of concrete for me. So however, whichever type of grade of concrete I want to use, if all my structural members are going to be one grade of concrete, I can just click on apply to all members and it's going to apply to all the members. You can see all of them now are 410 for my grade of steel. Rather, this is not concrete, this is steel. So similarly for concrete, I can actually select the grade of concrete I want to use. So for my concrete, I will use this or use 20, however that I want to use. I can also similarly apply to all. Now mind you, I mentioned steel. What I mean here is this is reinforcement bars. So this reinforcement bars means it is going to be casted with a concrete. okay, but this is steel bars. Sorry, these are steel members. Okay, so these are steel members. You can also select the grade. You can see for steel column is 270, for my steel beam 270. So however, you can change the steel grade from here as well. Mind you, like I told you earlier on, you can actually design a you can actually design formwork. Okay, so you can see this is a timber frame member that is giving you here. You can see your sheeting here. So so your formwork, to do your formwork is just for you to select any of the member, and once you select the member, you can see this menu for formwork is here. You can also insert column jacket. This column jacket is retrofitting. Okay, maybe the column section is not very sufficient enough. This is very useful for maybe an existing building. You want to retrofit that, you can just add the jacket thickness, let's say is 150. However, the grade of the concrete, grade of steel, you can select all of that and then just click on it. And once you click apply, you can see the analysis result will not be validated, so I don't want to go through that process anymore, but you can go through it to see how that is going to affect your design. Similarly, you can see this is your formwork. You can select the plate, you can select what thickness. You can see, just select the thickness, the joist at what this is 50 by 100 size. This stringer is 50 by 100 as well. However, once you just do that, you can click on renew design. Once you click on renew design, automatically it will redesign it for you, and then you will be able to have your formwork. Okay, so it may not display on your model, but that formwork, once we generate our detailing, you will see that formwork in our Prota detail. So similarly, for your column, for your beam rather, you can also do the same thing. You can come here, you can see this is the formwork. It's giving you a preview of how it's going to look like. You can just click on redesign. So once you click on redesign, once it shows you everything green, the design is successful. That means everything has passed. You can just click on OK. So we are good to go. We have been able to cover most of the major aspects of the Prota structure. Alright, so if you love what you are seeing, just like this video and give it a thumbs up. Subscribe to this channel. It's actually 100% free. Click on the bell icon so as for you to always get a notification whenever I post videos like this. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Make sure you stay safe and stay blessed. You can reach me on this number or call me on any of these numbers. Okay, today we are going to be continuing at where we stopped. We were able to do the entire model. We modeled steel members, reinforced concrete members. We were able to talk to a large extent about some of the major kind of foundations that we have, and then we did analysis, we did the design, and went to Prota steel. Now I want to take my entire detailing to my Prota detail. But mind you, if you come to drawings and reports, you can have a preview of how your detailing should look like even before you take them to your Prota detail. The essence of this, I believe, in my opinion, is that you can be able to see how your detailing is going to look like before you take them there. So as for you to do whatever adjustment you want to do on the detailing before you take them finally to the Prota detail. I'm going to talk about the Prota detail in this particular video. So but then this helps to guide you to be able to have a preview of how it's going to look like. So on the drawings and the reports, if I click on column elevation, for example, you can see these are all the list of the column. If I want to just have a preview of my story one column, a separate window is going to be created specially for this. As you can see by the right hand corner of my screen, you see column elevation st1. Although it's loading in the background at the moment, so we will have to wait for it. All right, so we are here. If you look at this, this is the column elevation for my story one. You can see the reinforcement, and then the column is just showing only the story one level, so you can see it's not really continuing, but you can see the reinforcement showing a continuity here. So that is that. Similarly, you can do that for every other structural member. All you need to do is come to your drawings and reports and click on any of these structural member, and it will generate that for you automatically, so you can have a preview of how the detailing is going to look like. If you are not very satisfied from your settings here, which I showed you in the previous video, you can come back and readjust some of the detailing settings. Okay, so that is that. So the next thing we will do, although okay, the next thing we will do is to just click on my Prota detail, and automatically the Prota detail will open the background. So I'm sure it's loading at the moment, so we'll have to wait for it. All right, so it has loaded. This is it. So so if you are new to Prota, which I suppose that a lot of people viewing this at the moment must have been conversant with Prota structure generally, only that most people have not really been able to go through the 2024 version. So this is basically the Prota detail for the 2024. If you look at this, you can generate auto generate detail. You can also start by creating a new drawing. Okay, what this means is if I click on auto generate, automatically to generate all the structural detailing in this particular project. So that is what it's going to do. If I click on start by creating a new drawing, that means I am manually going to be selecting them to generate those details. So what I will do is to click on auto generate details, and then I will delete them on the window and then generate them manually as well. So for you to have an insight of how to do this yourself, as you can see from the draw details, every level, or will I say every story, is actually selected. But you know, this story 9, if you have been following, what I have there is just the still member. So whether I leave it checked or not, the Prota detail will not generate the drawing for my still members. Okay, so but then I have all my story from the foundation level up to the level 8. Okay, so all of these are here. There are some settings that you can do here. If you look at this, this is option 2, and this is option 3. You can carefully go through all of these settings to see what it means. You can see show dimensions. That means you want the dimension on your pad footing to reflect. You want the strip footing dimension to also reflect. So however, you can check every of the structural member. The form plan side dimension can also reflect, but some of those dimensions may not be very necessary. Draw similars separately, so you can use this display column load. So that means the loads, although I was not able to show you how to display like your axial load on your column, so you can see how the loadings that are acting on each of the column. Okay, so you'll be able to tell what is the load that is coming down on your foundation at each column point. Although as we continue in Prota structure, but you can visit some of my videos. If you go down below the description of this video, you find a link to the channel. Okay, you find when you visit that channel, you will see a whole lot that I have been able to talk about Prota structure generally. You can see display column load. You can actually select that to display the column load. If I click on this column load, it gives me the option to select whatever kind of load I would like to show in my columns. So you can see the nodal load, axial load, bending moment, and the shear force. So whichever load I want to display on my drawing, I can just simply select it and that will be done. But then I would like to skip that part, and then the scale, very important. I can insert this on a sheet of paper. Okay, so like Prota detail is a stand-alone module, I would say. With Prota detail, you can generate your drawing from your Prota detail, edit your drawings in Prota detail, arrange them on your title block in Prota detail, and also print directly from Prota detail. So whether you have a formal knowledge of AutoCAD or not, you can use Prota detail to generate your drawing smoothly. So I will just only going to be giving you a little overview of what you can do and how to go about it, so you can sit down on your own and explore on it better. But like I will also repeat, I have covered all of these in my previous videos as well. So if I select this sheet, you can see it has different sizes of paper. These are different sizes of papers. Okay, like it's customary to use A3 paper in Nigeria. So however, you can use A3 paper that is for structural designs, but for road design, the size of the paper is usually different. Okay, but for structural design, it's actually A3 paper most of the time. I think that is the generally accepted size of paper that you can use for your structural design. So you can select the sheet of paper you will want to use. You can see the insert to sheet is selected. Generate sheet list, you can however select generate sheet list. You can do this, come back and try another set of settings in order for you to be able to understand better what each of these settings can do for you. Okay, slab hole slash drop rebars. I'm sure you understand where you have an opening in your slab or you have a drop and all that. Slab steel members, that can be checked. Slab reverse deflection, you can check all of that however you want it to look like. So you can see print alternative layer information. So what this means is that B1 will, if I select this now, where this is going to be B1, it is going to replace it with BB. So that will be bottom bottom, bottom top, top top, top bottom. I believe you understand that as a student of civil engineering, you must have been very conversant with these words, these terms. Hatching options, you can however come to this and select the hash however you want, because this is going to display on your drawing when you print it out. So you can just play around with it in order for you to understand better. So these are the list of the structural members that you can generate their detailings. Okay, you can see the form work is also included here. So you are going to see that form work that we actually created in our on our column and on our beam. If I leave this checked, that means it's going to generate those detailing for me. To draw on separate files, inserts to sheets, you could remember we have done all that. So but then I can also select draw sheets side by side. I can select that, generate sheet list however I want. Like I said, you can just keep trying each of these settings to see what it can do. Once I click on that, I will click on the window and then my detailing is going to start loading. All right. So if you look at this very well, you will see that the detailing is already generating in the background. So we will have to wait for this to finish generating. Okay. Right, that has loaded. So if you could remember, we checked that sheet list. So this is basically what that sheet list is all about. As you can see, it's showing us beam elevations. It has actually listed all the beams that we have, and then similarly for columns, as you can see, for our floor plan, which is the form plan as well, you can see all of that. So it is not really very necessary to really have this though, so you don't really need to check that as an option, but it's important for you to see how that looks like. As you can see here, we have these drawings on our template. Now mind you, you can edit the informations on these templates. There is a way to go about it, and I'm going to show you that. So you can see for yourself, all our drawings have been generated at each floor. This is the foundation. Okay, this is the column plan. If you could remember, this is our core wall. These are all column. Let's go down to this part and show. Okay, so you can see this is the core wall. These are the columns. So I'm going to delete some of them, or I don't necessarily need to delete though. I can still create this manually to show you how to generate them. If you could remember, we had two options to create new, or you should select the auto generate detail, right? So you can see this is our column detail, our beam details rather. So it goes on and on. It's it will go as far as showing you. Good, this is that form work that we created. Remember, this is for the column form work, this is for the beam. The form work is important as well. You can see it will go as far as generating the quantity table for you. So as an engineer, probably you want to know how many number of maybe the plank that you will use for your formwork on your structural members. You can simply use the Prota structure to generate all your formworks, and you will know the exact quantity that you will need for the project. Okay, so that is that. We have been able to generates our detail, as you can see obviously here. But mind you, like I said, you can as well generate your detailing from here manually. For example, you can see this is form work. At this level, if I right click this and I click on draw, automatically it will draw. If I also click on form plan, that means everything about foundation at, and then their form plan, that at is the layout, it will generate them for me automatically. That is basically what it means. So but let's say I want to generate for only this foundation, and I click on draw. I can just drop it at any anywhere around my window. Automatically that will be generated. As you can see, it has been generated. All I need to do is just to zoom. It's loading, it's still loading in the background. So we'll have to wait patiently a bit. So the model is a bit large, so sometimes it may take a little while for it to generate. But you can see this is the form plan at foundation. Sorry, this is the foundation layout that has been generated by the software. So similarly, you can do that for all of them. If you look at this what they call it, these columns, it's important sometimes to generate your column, draw column, draw column elevation, draw column elevation one by one. I'm coming. So if you draw, there is one settings I am looking for. Aha. So if you can see this is story one. If I click on this that is pointing this direction, you will see a drop down menu will pop up like this. You can select any particular column. So let's say I want to have a continuous column. I will click on draw column elevation through stories. Okay, it's important most of the times that we use this yeah, through all this story, and I'll click on OK, because in reality this is basically the best way to represent your column detailing, so as for you to see your reinforcement starting from the foundation level up to the topmost level of your structure. It's very important that this is represented this way. But you can compare this with this. You will notice that there is a difference. For this one that was generated automatically, you will realize that the software had to break the columns at each floor. Okay, so but I just want to show you that the software has the capacity of generating your columns all through your stories. Okay, so you can see this is at each level, and it's not a very good way for me to represent my column. I would rather prefer this column to be like this no matter the number of stories. Okay, so this is going to be way better to represent it this way. So you can literally select, you can generate all your detailings manually from here. Okay, it's very easy to do that. I have shown you. So any structural member you want to generate, all you need to do is just to come by the left hand corner of your screen. You will see each of the structural members. Just select and it brings out a drop down menu like this. You can select any story and generate that member. Okay, so mind you, Prota structure or Prota detail is a bit wide. Okay, there is a whole lot to talk about as far as Prota detail is concerned. It's not just to generate your detailed drawing. There are some designs you can also generate from here, because like you know, your staircase can be designed, analyzed, and the detailing will be generated for you here. All you need to just do is to specify type in your informations properly, and the software will generate them. It's like a template. All you need to just do is just to fill in what you want there, and it will be analyzed and designed. If it fails, it will tell you. If it passes, it will tell you. It's very straightforward. It's very easy to use. Okay, it's one of the most flexible and very straightforward software for most engineers that are looking for a way to achieve their design, or you are new to design. I will tell you that Prota is one very easy, friendly, and um, software that you can ever use. You can see here it has from here you can see this symbol looks like a staircase, so it's telling you this is a staircase. This symbol is for a retaining wall. This is retrofitting. This is scaffold. This is cover. This is isolated part. This is swimming pool. So all of them, as you see them as they are like this, you can generate your design from here automatically. All you need to do, like I said, is to type in, put in your information, and automatically that will be generated. So whatever your information is as regards to your staircase, just type in those informations here. Whatever you put in here, automatically it will update and just redesign. Once you redesign, it will redesign it for you. Once you are done with the design, you can generate your design reports. Very easy. It's just a single click. Automatically your report will be generated. But you know, your staircase, you use the architectural drawing to actually generate your staircase. So that architectural drawing, you will be able to know what is your riser, what is your tread, what is your how many what do you call it, the number of steps that you have in your, and then the waist. Okay, so you need to know all of those information, and in most cases, most of the major information that you will have to generate yourself as the engineer is the waist. Okay, but the height, the width, the landing length, all of these, this plate thickness, these are the information you will have to uh, generate based on your discretion as the engineer. Then the dead load, the life load, it is your responsibility. So these are the informations you have to provide, but in most cases, almost everything here is given to you by the architects. Only that the riser is given, the width is given of your, that is your this is your thread. Okay, so it's usually 300, which is 1 foot. The rise is usually 150, but sometimes you may have 175. However, this is from the architecture. The number of steps is also from the architectural drawing. So that's basically it. All you need to do is just to type in your information. You can see you have different templates here for whichever kind of staircase you want to achieve. You can see spiral, you can see load bearing, you can see doubled arm kind of staircase. So all you do is just to select. Once you select, you type in, fill in your information that suits the architectural drawing, and you design, you to generate your design report, and you click on detailing. Although this is not up to date, has not been designed, so I will have to redesign this because I have made a major change on the design. So you can see the design is just a click. Once you click on redesign, in few seconds that will be generated. It's as simple as ABC. You can see the detailed drawing has been generated for you. Similarly, for your retrofit, all you need to do is just to click on retrofit wall, and a template like this will come up. You fill in your information just like I said earlier on. You already know the size of your column. You know, retrofitting is usually used for columns that are are already maybe failing, or they are no longer sufficient. Yeah, they are maybe failing, and you want to reinforce that column or increase the cross section of that column, so you retrofit it so it's a column uh, for wall, for beam. So you can just fix in your information. Once you put in the information, these are some of the major parameters that you will need, and then you type in all of that. Like, this is just generally an deep overview that I'm giving as regards to the software. When we proceed, I'm going to carefully go through each of these structural members and show you how to come about your designs with them. You can see our retrofit has been generated. Similarly, for your retaining wall, all you need to do is just to click on this tab here called the cantilever retaining wall, and automatically, it's like a template, it will come up for you. Type in your information. This is the geometry of the cantilever retaining wall. You can use a share key or a parapet, however, whichever kind of retaining wall you want to use. You can see it's very easy once you get your geometry right. Okay, because you as the engineer, you have to use your discretion to know all of these things. You type in all the information. You must have your soil report for you to actually design a retaining wall. Okay, because if you are designing a retaining wall, you are definitely retaining something, either it's soil or water, whatever you are trying to retain. So you will have to get your soil report. It's very important. In most cases, they are soil, so you fill parameters, analysis, settings. You have to do your settings. You can see it's giving you a little preview of how the analysis is like for this particular retaining wall, and it's telling us everything here. The stability analysis is successful, it has passed. You can see everything is green. So if it's showing you green, that means you are good to go. If it shows you red, that means it has failed. Okay, so however, you can see there are design codes to this. Whether you are using Euro code, American code, or Turkish code, all you need to do is just to select, and that is that. Once you do that, you can click on prepare drawing and click on yes. It will generate the analysis for you automatically. You can see the analysis is being done in the background, so we will have to wait for the analysis. Once it's done, automatically we can just find anywhere around our window and click, and that detailed drawing will be generated. It's as simple as ABC. If you already love what you are seeing, please just like this video and make sure that you give it a thumbs up. Subscribe to this channel. It's actually 100% free. Click on the bell icon so as for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Okay, so we can as well go to for the case of pile. I want to believe this is pile. Yeah, that's pile. So for the case of pile, it's the same thing for all the structural member that you can ever think of. All you need to do is just type in your information. You can see this is a circular pile. You can use any pile cross section you want to use, but I think column circular piles are the most common kind of piles you can find. So all you need to do is specify pile length, pile penetration, reference level, concrete side cover, and all of that. You put in your information and it will generate that for you. Very important that you do this. Okay, so you can, this one can only allow you generate a single pile at a time. But you can also design your pile directly from the Prota structure itself, and then you just come to Prota detail and generate the detailing, right? I have just done a little overview on it, but I did not talk extensively on this particular series of Prota Structure 2024. But by the time I will going to talk more extensively on Pile, but if you still want to have a deeper insight, you can still check some of the previous videos I have done on Pile Foundation using Prota Structure for previous versions of Prota Structure. The most closest to 2024 is 2022. So with the 2022 tutorials, they are still going to be very relevant for you as far as 2024 is concerned. So that is for pile. You can see this is your pile cap. So similarly, just like your pile foundation, you cannot, for you to have a pile foundation, you must have a pile cap. Okay, very important. The both of them work hand in hand. So you will specify the number of piles that should be on your pile cap, whether it is 2, 5, 6. You can see the list is very numerous here. In most cases, I don't think you will have up to 100 pile on one pile cap, but it's very possible anyway. It depends on the magnitude of that particular project. Piles, location, pedestal, material option is just very similar to every other template that I have spoken about. So whichever type of pile that will be on that cap, you will just select it from here. Okay, this is all part of geometry of that pile, and that is that. It's a generator for you. So if you want 3 number of piles on each cap, you can see automatically it comes up. So it's as simple as ABC. So similarly, that is for your pile cap. So the same way for some engineers, maybe in other parts of the world, people still do scaffold design. So you may want to design a scaffold maybe for your project as the engineer. I think is very ideal for you to do scaffold design because of the safety. Although now we have people who are into the business of renting out scaffold, but as an engineer you may want to design your scaffold for your personal projects, and then you can use your Prota structure to do all that. So you can see the standard, you can see, you can select from here. You can see the section. This is a circular hollow section. You can use this, which is rectangular. This is square. However, whatever section you want to adopt, you will select that. And then these are the transoms. You can the ledger, the brace, the guardrails. Just as the name implies, they are all here. These are all the features of your scaffold. Okay, so we are going to also be talking extensively on all of this. All you need to do is just to analyze. If you, once you are done specifying, you have to specify the geometry for all of these structural members. Once you are done, you can just click on detailed drawing, because the scaffold is also a structural member. They are all structural members. Okay, so you can as well design your scaffold for your site. We have the swimming pool as well. So the swimming pool, okay, so this is your scaffold. It's very straightforward. You can see how great these detailed drawings for your scaffold looks like. It's very wonderful, if I must say. So it's very good. I think they have done a very great job as far as scaffolding is concerned. You can see how very great the detailed drawing is. You can simply print these drawings out and then they fabricate them for you exactly to this standard. Swimming pool as well is here for you. You can also do a swimming pool design. You can design your pool. All right, so you can see how your pool is like. The good thing about this is that you have from this gallery uh, an option to choose however the geometry of your pool is going to look like. I think this is one of the most very common current design geometry that you can find, right? So you can as well even rotate this. You can view this from the top view to see this from here. You can see slab 1, slab 2, so you can follow based on what you have in the architectural drawing. If this first slab, you can see here it slopes, and then this is this deepest part of this pool. So however you can follow the geometry of the architecture to achieve your model. Okay, you can as well use a wall geometry and all that. So like I said, I'm also going to still talk extensively on all of this even as we proceed, but these are the existing templates that you can play around with. So if you are lucky enough that your pool comes in any of this shape, you can just play with the dimension in order for it to fit in exactly like the way it is. So that's basically how because you can see this is the slab 1. The slab 1 gives you like a table for you to see you can play around with the length, the width, and the breadth and all of that. Okay, so that is that about your pool. If you are satisfied with what you have, you can simply assign all your soil information and then analyze and design. You can generate your detailed drawing for this design. So far so good. You can take out time if you have this software and go through your pool and every other structural member. Like I said, I'm not really going to talk very extensive on each of them. I'm just going to give you like a general overview of some of the major templates that we have here. Like I said, Prota detail is a bit wide as well because there is a whole lot you can do with Prota detail. Like I said, in Prota detail is a standalone soft module that you can use as a drafting software as well. Okay, because you can use this to do your drafting just like the way you use your AutoCAD for your drafting and annotation purpose. You can also use your detail for that. Like it has all some of the major AutoCAD tools like your line, your offset, your array, your trim, your move, your copy, and all of that is here. You can see it has some of the major AutoCAD settings like the polar tracking. You can use the polar tracking to achieve a very straight line, whether horizontally, vertically, or diagonal line. You can as well achieve by using Prota structure. So it's very straight to user friendly. So if you are very familiar with AutoCAD, I don't think you have any issues with doing any detailing here manually, because even the shortcut keys are the same with Prota with AutoCAD. So just like you use for your AutoCAD, you say L for line, is the same thing with Prota structure. Just like the way you say CO for copy in your AutoCAD is the same way you do copy in your Prota structure. The same way you do M for move, as you can see, if I press enter, I can move any of these objects. I will right click and I press enter, and then I can simply move this. You can see. So that is that. You can see all of the major AutoCAD tools that you can use for your drafting are here. You can see the fillets, the chamfer, fillets, they are all here. Break, extend, trim, so, and the shortcut keys are the same. That is one good thing I can tell you. The shortcut keys are the same. So if you are very familiar with AutoCAD, then Prota Detail is is going to be a piece of cake as far as detailing manually from here is concerned. Okay, because you literally don't really need to learn anything afresh, because the tools are the same and the shortcut keys are the same. Okay, and then you have the culvert. This culvert, although I believe that they are probably still working on it, because you cannot generate, it doesn't provide reinforcement. You will have to manually insert those reinforcements on your plans. Right, so that is that about culvert. Let's see what other thing we have. This, I think this is pit foundation. So everything here is just like the way I have explained earlier on. You can change however the cross section of this is like. You can just play around with it. You can turn off any of the sides. You can see we have left side, we have right side. You can turn them off. You can play around with the thickness, the width, the length, the height of the cross section here. Very easy to use. Okay, right. So that is that. You can also just take your time and go through it extensively yourself to understand better what you can do. So so far so good. We have covered extensively on some of the major template. I am sure I have not been able to really cover fully what you can use Prota Detail for, but I have been able to cover extensively on Prota Detail. On the next episode, I am going to go a bit more deeper to show every other aspect of detailing Prota Detail that I have not been able to cover. Mind you, we have the engineering utilities. On the engineering utilities, there is a whole lot that you can do, most especially for hydraulics. You can see here in your hydraulics, you can specify whether it is rectangular, trapezoidal, or circular. Okay, you remember we did pit foundation, so that it's very important for you to design your channel, so for you to know, you can see whether for a uniform flow depth or gradually varied flow. All that can be done from here, and then it has some other unit conversion that you can do from here, whether you want to convert from millimeters to centimeter, whether you want to convert from decimeter or inches or feet to any other uh, unit. So you can do all of that from here. So it's like a calculator that helps you to calculate from centimeters to meters, from millimeters to centimeters, however you want to do that conversion. Automatically it does that for you. So you can do for length, you can do for area, for volume, for mass, for force and width, for pressure and stress. So all of that can be done directly from here. You can do a simple beam analysis. This is one very good future for those in a classroom or even for real life projects. You may probably just want to do a simple analysis on your structural member, maybe on site. whether for a concentrated load, which is the point load, or load increasing uniformly to center. However, you can play around with this just to fit in exactly how those loadings are acting on your member. So whether for uniform load, you can actually just simply do the analysis. If you know the load, type in those information. However, specify the distance of force from let. So all of this information can be specified. So this is the starting point, is definitely going to be 0, and then from here to here is going to be 3 meters based on what I have here. So you can change the width, the length of this beam. For example, if the beam is 6 meters, if I press this, you will have to play around with this. You can see from this support to where this load is acting is actually 3 meters, but here there is no load entirely, and this is another support. So you will have to play around with it to um, fix your information right, okay, so that you know that okay, you are putting in the right informations how you want it, and then it will automatically analyze it and design it for you. Okay, so the distance of the force from the left is 3 meters. So sorry, the entire length here is 6 meters, but the loading that is acting on this is just 3 meters. So if I want the entire load to be acting at 6 meters entirely, you can see that load has readjusted. Now it is uniformly distributed along the span of the beam entirely. So that is good. If you monitor this, you will realize that whatever value I am having as my maximum deflection is going to change automatically by itself. So if I change it to 2 meters, just take note of what is going on. You realize that the information is changing. So that's basically how this works. You can take out your time and play around with it. Rebar area calculator for your area of your reinforcement bars. You can do all of that from here to maximum spacing, minimum spacing, bar spacing, step, span length. You can calculate the rebar, the area of your reinforcement. Okay, select the reinforcement. Automatically it will tell you the area of your reinforcement. It's a very powerful feature, this engineering unit. It does a whole lot for you. You can see here, this is for your hook length. You can also take your time to go around this, then cover and anchorage for your concrete cover. Very, very important. You can also do all of that, and you can print your reports from here automatically. Please make sure you stay safe. If you like this video, make get in where we stop. We have been able to cover extensively on Prota detail. So I promise that we are going to cover up all those areas that we are not able to show using the Prota detail. Like with Prota detail, you can do a whole lot. You can bring out a cross section of your detailing. Okay, by default, Prota structure does not generate the cross section of your slab, and if you check all of these drawings like a slab and beam layout, you can't find the cross section. That doesn't mean that you cannot achieve it from Prota. You can achieve all of that from Prota. You can insert the dimensions of all of these from Prota structure directly. So it's actually a very great package to work with. So I'll be taking you through that process, showing you how to come about your cross section. I think we skipped our slab strip. Okay, because I can't find the slab detail here. This is serious. Anyway, like I said, Prota is actually wide. So there is a whole lot to talk about as far as Prota structure is concerned. That aspect skipped my mind. But then as we progress in on this software, I'm going to keep showing you, giving you more value from Prota structure. Okay, without wasting too much of your time, I'll be showing you how to come about your cross section right away. So like I said, I can't find the slab detailing because I did not generate the strip from the Prota structure. You have to do a slab strip. It's very, very important to do a slab strip. So let's see if I can just demonstrate something quickly. If I click on slab strip, right, I'm just going to start by the very simple one. Let's say I pick from here to here. That will be from beam to beam. So I'm starting from a beam. I will take that again. So I'm using an analytical strip, starting from a beam. You can hold on your control for you to have a straight line ending at a beam. Okay, so this boundary condition is very important. If you don't set it right, you will not get it. So as you can see, this means is a continuous, is also continuous here. This is telling you you have a cantilever here, it ends in a cantilever. So that's basically what these conditions mean. Okay, so if you want to do for this, you will have to, you can take it from the end is the beam, or however, if you are calling this, or if you want to do it this way, you are starting from a beam here, and then you are ending with a cantilever. However you do it, you are right. So if I'm going this way, if I want to take this way, now because this is a cantilever, right, so this is a cantilever and this is a beam. So if I'm starting from a cantilever point, I will click on cantilever and then click on beam. I'm ending at a beam. So however, if I'm going to do it this other way around, I will have to switch this way and make this cantilever. I hope you get the point. It's very easy to actually make use of. So just hold on your control in order for you to get a straight line. Now the strip direction is closer to Y direction, but marked as X direction strip. Do you want to continue? I will say no, because that is a mistake. I'm supposed to switch this to Y direction. It's very important, but I'm going to leave this as it is, just for you to get. But similarly, if I want to do this for this, you can see this one is supposed to be, this is in Y direction. So but you can see it's showing X, which is X direction, which is not correct. But then you have to do it the right way by switching to Y direction if you are going vertically. Okay, this is horizontal and this is vertical. So if that is correct, if I'm going to do for this, I will just hold this and hold on control, and you can see that has been created. So if I want to create the reinforcement for here, this is going to be cantilever and it will end inside the slab. Okay, so it's very, very important that you get this very, very right, or else your detailing will not be correct. You can see I made a mistake again. I'm supposed to switch this to X direction. I don't know why I've been making mistakes, but the main thing is for you to get the concept behind the whole thing. Okay, for this, if I'm going for X direction, it's supposed to be beam to beam. Okay, so I will click on this and I will hold on control and I will release. So this is basically how to get your strip. Once you have been able to do this, we can probably just close our detail and probably open it in all over again, so as for us to update our detailing from our slab which we omitted from the beginning. So that is that. So let's wait for that. I'm just going to close the detail, so it's loading in the background. So I'm going to reload the detail and wait for it to load in the background. Yes, I'll click on yes. All right, so we have been able to load this. Earlier, the first time we used the auto generate detail, this time around I'm going to use start by creating, in order for you to see how this works. Okay, so once you click on start by creating, you can see it only brings you to this window. Even if you click, the detailing won't generate automatically by itself. You have to manually create your detail by just simply right clicking on any of the structural member and click on draw form plan. Although it's not really manual, the detailing is already there. It's just for you will have to click the command for it to come up. It's different in the case of automatic. Okay, similarly, just like we did earlier on, you will have to select the size of your paper. Once you select your paper size, and you can click on OK, and then do every other settings you need to do. There is a setting I want to really turn off, because most times it takes time for it to load. I can't get my hand on it immediately. Okay, generate sheet list, this is one of it. Okay, I'm going to leave everything as it is, and I will click on draw, and I will just click anywhere on my window to generate my detailing. So as you can see, this time around our detailing has been generated. Amazing, right? So if I want to come up with the cross section of this slab, it's very simple. All I need to do is to come to my detail library. Once I come to my detail library, I can click on plan section. So if I click on plan section, all I need to do is to select my first point. If I want to, now this menu allows you to select whatever you would want to show in your cross section. Okay, so if I want the dimension to show, it will show the dimension. If I want to always draw horizontally, I will have to check this, but I will advise to always leave this on check, because you may want to take a cross section vertically as well. Show axis dimension, all of these are also very important to have them in a cross section. All right, so once you do all of that settings, but you are at liberty to check and uncheck any of this. So if I click on the first point, I would hold on control in order for me to have a straight line, and I will click. So it's very automatic, it's automated. I will not have to do anything on this. The cross section will be generated. As you can see, this is the cross section on my cursor. It follows me to wherever I want to drop this, it will go. So if I want to drop this here, you can see my cross section has been generated. Now if you look at this, you can see the reinforcement, but you can see it's not very straight. It's because my line is not straight. Like I told you, this interface is more like the AutoCAD. There's a whole lot of relationship with AutoCAD, so you can leave it on polar tracking so that whatever you do will be very straight. Okay, so I will click my first point this time around again and click my second point even without me holding on control. You can see it's giving me a very straight cross section. This is amazing, right? So you can see these are the supports 1 2 3 along this horizontal direction. This is what we are going to have. So if you are very conversant with manual detailing, you can double check this to confirm what this cross section is giving you is 100% correct. Okay, so similarly you can do that along the y direction. All you need to do is click on the first point, click on the second point, and any point you can take a cross section of anywhere. So if I have this, I can place this other cross section here, for example, and you can see that has been generated for me. Prota structure is a very interesting software, as you can see for yourself too. Like I said, it's just like the normal AutoCAD interface. If you have this vertically, you can as well rotate this by typing RO for rotate. Once I click on that, I can click anywhere as my points. Okay, so you can pick any point that you will want to rotate from. So if I'm rotating this way, you can see it's following me and I can drop it there. But definitely this is not where I want this to be. So that is that about cross section. So you can do your cross section, although I have just mistakenly on do that particular command and then starts taking me back. So you can take your cross section along any direction for any structural member. You can achieve that. Okay, so make sure it's on polar tracking. It's very important. This will really help you to get a straight line or any straight cross section on your design. So that is that about cross section. Like I said, similarly, this is slab and beam layout. You can as well take the cross section of your slab and your beam layout. Cross section is very important. It helps to give a better detail or information about whatever we are designing or whatever we are representing rather. So that is that about cross section. Similarly, just like I said, you can do your dimension. You will not even have any need to actually take your design at any point to AutoCAD. Okay, because the software on its own, you can achieve a whole lot with it. So basically, most of what you can do with AutoCAD as far as drafting is concerned, you can achieve it with your Prota structure, right? So that is that. You can, oh, this is a vertical dimension, this is horizontal. You can see this is align. This is angular, where you have like an angle, right? You can get the angle of so you can know this at what angle is this. So basically these are some of the most powerful okay, you can see this is for diameter. So in a case where you have like your reinforcement, you can easily check the diameter of that particular reinforcement, or like a cycle. You have a cycle. If you want to know the diameter of your cycle, right, you can get that by your diameter dimension. You can have a radial dimension as well. Dim continuo is very important, is a very powerful tool. Like for this case where I drew this dimension, it's important that I use continuo. I know most of you watching this video right now are very much familiar with AutoCAD. So you use dim continuo, which is to continue your dimension. Very important. You can have a continuous dimension like this. Okay, so all you need to do is just to, all right, so that is that about dimensioning. All of these tools are similar to the tools that you are already familiar with in AutoCAD, and these are the same tools that we have here. So they are always here in order for you to most of the most common tools will always be there on your window for you to easily pick, because these are assumed to be the most common tools that you will use on every project. So they are always here for you to pick them quickly. The settings, like settings and parameter manager, from here as well, you can set a project preference, that is, you specify calculated, control, drawn, and all of that. I believe some of these settings are also very much available in your Prota structure software. The Prota module on its own, the Prota structure module, this is Prota detail that we are on, which is part of Prota structure as well. So similarly, you can come to layers and textile. So if you are very familiar with AutoCAD, I am sure you will definitely not have a lot of challenge with this. So this is also under the general settings that you can do as far as each of your structural member is concerned. Okay, other column settings, beam settings, they are still under the settings and parameters manager, which we already know about. All right, the project header, all of these are still there. Okay, so it's really interesting to use the software under your design library. It's just similar to what we already have here. We have all of these available here already. So these are assumed to be some of the most common, maybe structural members or tools that we can actually use in Prota structure. So under the design library, it gives you the list of the structural members that you can design directly from here without you having to take it to Prota structure to do a model. Okay, so it has, these are like these are like templates, okay, that you can make use of, and we have been able to highlight a little about most of these. I think what I have not really shown you so far is on the pad footing, and then yeah, I think basically pad footing, which I'm going to show you that. So design report manager is just as the name implies, where you have all your structural members. You can generate your design reports for each of them from here. Okay, so I believe you already have some little insights from the Prota structure on itself. You can do all of that from there. So rebar, insert at single point. These are some tools that you can use to maybe add reinforcement bars, You can insert using 2 points and all of that. This will help you to achieve some detailing directly from here. Like I said, but this is not a very extensive. We are not really going very deep into each of these designs using the Prota structure. I have just been able to give you an overall overview of what Prota structure can do for you. Where we started from the Prota structure itself, we went to Prota steel, and then now we are in our Prota detail, just to give you an insight of what Prota structure can do so far. So lastly, and this is going to be the end of we are going to this particular episode will be the last we on this overview on Prota structure 2022 so far. So before we end this, I'm just going to show you the last thing which I'm sure I did not cover in time past. So this is it, the pad footing. There is nothing different from every other structural member that I have shown. It's just to click and click on any points to achieve that. So if I click on the pad footing, is supposed to load a menu for me where I can insert all my information. There are cases where you can have an isolated part. Okay, designs are really wide. It comes differently. So in that case, you may probably have to use the Prota detail to achieve that. So if you know the size, the width, the length, and all of that, although it's a design software, it will design and tell you if it passed or it has failed. So but you can see basically what I have. Based on what I have here, is telling me that it has passed. Now this is just the geometry. I have not really subject this to a load, but you can see the depth, you can see the footing, tapered height. There's no, yeah, it's just going to come straight. So we can leave it as it is. Concrete cover, you can play around based on what you want to make use of. And then the size of the column that is going to come on this particular footing, if it is, let's say, 230 by 230, just for example. And then the depth of this, let's say, is 350 L LX, let's say 1 2 by 1200. Okay, so you can just do all that and design it. Once you design it, it will tell you what you have, although it's based on the load that is coming on it that will determine what you have there. This is just the geometry of this particular column, footing rather. Okay, now like I said, whatever you are doing there is based on the loading that is coming, and that load is the axial load from your column. Okay, so that is what will affect your design itself. Okay, I believe we have already spoken extensively on all of these things, but then I'm still going to go all over again on Prota structure to talk about each of these members. We pick a really live project and do together. So we have come to the end of the general overview of what Prota structure can do for you. So if you really love what you have seen, make sure you just like this video and give it a thumbs up. Subscribe to this channel. It's actually 100% free. Click on the bell icon so as for you to always get a notification whenever I post videos like this. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. So make sure you stay safe and you stay blessed.